Okay, so now we are going to discuss some NET and ECAT sample questions which are related to the topic sets. This video is basically the second part of this topic. I've already uploaded the first part. So here we are going to start off with the 16th question. The rest of the questions are in the first part. So let's get started. Question 16 says let A equals 1 2 3 4 5 and B equals 1 2. Then we have this question. Okay, we need to find this. Let's just write down in the simple form which is easily understandable by us. So this is basically this. I can write it as A minus B. Okay, so I can write this form into this form because like this form is easily understandable. Now let's just break it down. Now let's just talk about A minus B. If I talk about A minus B, in this set, I am going to have all the elements of A, excluding the elements which I have in common in A and B, right? So B has 1, 2, A has 1, 2, 3, 4, 5. 1 and 2 is common. Obviously, I need to cancel this part and I'm left with 3, 4, 5. Okay, so an easy understanding of A minus B could be that you need to take out the elements of B which you have in A, and the elements of B which I had in A are 1 and 2. So I simply have written the set A without 1 2, right? So this is A minus B. Now if I do A minus, now I'm doing for this whole thing A minus 3, 4, 5, I am going to get 1 and 2 because like in A I have 1 2 3 4 5, and this time around I have to subtract 3 4 5. So if I subtract 3 4 5, I'm left with 1 2 only. So this 1 2 is basically the set B, right? So C would be the answer. So in short, just know that this notation is not that easy to understand, to interpret. First step is to write it down in such a way that it is easily understandable. Once you are able to understand it easily, then you can solve any question. Okay, let's talk about the 17th question now. So here the question says na. This basically means number of elements in A, right? This means, this implies number of elements in A, right? So in A we have 20 elements, in B we have 16 elements, and um, in A intersection B we have 10 elements. So how many elements are we going to have in A union B? Okay, so in A union B we are going to have all the elements of A, that would be 20, plus all the elements of B, that are going to be 16. And the other thing is, which is very important about union, is that we do have elements of A, we do have elements of B, but the elements which are coming in common, we just write them once. So we can see that 10 elements are common in A and B, and this 20 plus 16 has those elements twice. Since I have to write those elements, I have to include those elements once only, I am going to subtract it with 10. So I am left with 26 only. I repeat, when we have A union B, it is a rule. We write all the elements of A, all the elements of B, and if we have something in common, we subtract it. Why? Because when we are writing all the elements of A, all the elements of B, if something is common, that is coming two times, right? Let's say I have an element 2 in A and I have that 2 in B as well. Now when I will write down this sum, I will basically include the number 2 two times, right? So in order to get rid of that number once, we just subtract the common elements of A intersection B, right? So in general, as a rule, just know that whenever we have to find out the elements of A union B, we do elements of A plus elements of B minus the elements of A intersection B, right? So that is going to be 26 in our case. So B is the answer. Okay. So we are done with the 17th question as well. Let's talk about the 18th question now. Okay. So 18th question says A minus B equals B minus A if and only if. Okay. Now we have two sets here, and they are saying that A minus B is equal to B minus A. Now that is only possible if A and B are equal, right? Because let's consider A option. If I think of this, A is a subset of B, right? So if A is a subset of B, so obviously here I am going to get null set, because like B is the bigger set and A is the smaller set. So A minus B would give me null set, because like when I will minus B from A, I would not have any element in this set. But if I talk about B minus A, I would have, it is quite possible that I would have any elements over here, right? So A is not the answer. Similarly, B cannot be the answer. And if I say D cannot be the answer, because like if I'm subtracting phi from B, like over here, if I am subtracting phi from B, I would get phi. I agree, right? I am going to get phi in this case, but in this case, I would get B. So these two are not equal, right? So the only option which best suits us is C option, that A equals B, because only then I am able to, I would be able to get phi on both sides, right? So only then it is equal when A equals B. So C is the answer. Okay. Now let's just discuss the 19th question. Okay. B minus A dash A complement. Now I need to choose a symbol, right? Either B minus A equals A dash, or B minus A is a subset of A dash, or A dash is a subset of B minus A, or none of these, right? Okay. So like we have a few options. Now let's talk about it. So here we only have two sets, right? Here they have only talked about A and like B and A. We do not know if there's any other set, any universal set and stuff like that. So one might think that B minus A is equal to A complement. Yes, this would have been our choice if B was the universal set, right? If B was a universal set, if I subtract A from B, like if I take out all the elements of A from B, I would definitely get A complement. But I am not sure if B is my um, universal set or not, right? So here the option which best suits us is this option, that B minus A is basically subset of A complement, because A complement is going to have everything except A, right? B minus A has B other than A. It has all the part of B except A. So this is basically going to be the subset of A complement. It could be that it is equal, but it is not necessarily true, right? So we are going to go with the C option, because C option is something which is going to hold for every situation, no matter if B is the universal set, no matter if B is a random set in the collection of sets, right? Okay. So we're done with this as well. Let's talk about the 20th question now. Okay. So if A is 1, 2, and if B is 3, 4, then 1 does not belong to. Okay. Now, obviously, A has 1, 2, and B has 3, 4 only. So this thing is very obvious that if I choose A option, obviously 1 belongs to A. So A cannot be the answer. If I talk about B, definitely B has 3, 4 only. So 1 does not belong to B. So this means that this is the answer, right? So basically, this symbol right here is doesn't belong to. Okay. Because if we have this, we say that it does belong, and if we have this with a dash, it means that it does not belong. Okay. So we are done with this question as well. Okay. Let's talk about the 21st question now. All right. Now we have A cross B equals B cross A if and only if. Now, the first thing is to understand what is A cross B. A cross B is basically going to be a set where we will have ordered pairs such that A belongs to A and B belongs to B, right? So in A cross B, we are going to have ordered pairs only, and this element would belong to the set A, and this element would belong to the set B, right? So we know what A cross B and B cross A would mean. Okay. Now, the thing is that A cross B equals B cross A if and only if. Okay. So that is possible, obviously, when A is equal to B. Why? Because obviously when A is equal to B, only then I am able to get similar ordered pairs, right? Otherwise, if A is a subset of B or if B is a subset of A, I cannot get similar ordered pairs. In order to get this equal to sign, I need to have similar ordered pairs for this and this, right? So that is only possible when A or B are same. Only then we are going to get same small a's and same small b's, and only then these two sets would be same, right? So A should be equal to B for this condition. This means that C is the answer. Okay. Let's talk about the 22nd question now. If a set A has 3 elements and B has 6 elements, and A is a subset of B, then the number of elements in A intersection B would be. Okay, now obviously we know that A is a subset of B and we are talking about A intersection B, right? So A intersection B is going to have those elements which are common in A and B. Now A is a subset of B, right? B is this big set, A is this small set. And obviously the common elements are the elements which we have in A. So we only have 3 elements in A. This means that the intersection would have only 3 elements in common. So A is the answer. Because like A is the smaller set, which is the subset of B, and A only has 3 elements. So 3 elements would be common. This is the shaded region in this case. Okay. Right. Now we have the 23rd question, which says A intersection A union B complement. All right. Now let's talk about A union B complement. This is basically going to have A and B both. Like this is going to have the whole set, the universal set, excluding A and B, right? So obviously now this is the let's say this is the universal set. This set is the universal set without A and B. Now if I take intersection of such a set with A, this set A union B complement does not have A and B in it. So obviously if I'm taking intersection of A with such a set which does not have A and B in it, obviously I'm going to get no elements in my set. So this would be a null set, right? So C is the answer in this case. Okay. Now we have the 24th question. So it says, which of the following is smallest set A such that A union 1, 2 is this? Okay, now obviously to get 1, 2, 3, 5, 9, at least A should be 3, 5, 9. I mean, A could have been 1, 2, 3, 5, 9 as well. But here they want us to find the smallest set, right? So we do have 1, 2 here, but we do not have 3, 5, 9. So A should have at least 3, 5, 9. So definitely this choice is here in the B option. So B is the answer. Okay, now we have the 25th question, which says if the elements in A are 3, if the elements in B are 6, and A is a subset of B, right? Then the number of elements in A union B, okay. In A union B, we have the elements of A plus the elements of B minus the common elements, right? Now, obviously, the common elements here would be the set A, that is 3. So, we are going to have 6. So, C is the answer. Now, in one of the previous examples, we have just discussed that to find the number of elements in A union B, we write down the elements of A, we write down the elements of B, and we subtract it from the elements which we have from the number of elements which we have in A intersection B. Now, here they have not mentioned the number of elements in A intersection B, but they have shared this information that A is a subset of B. Now, obviously, if B is a big set, A is the small set. The common elements, the intersection elements would be all the elements I have in A, right? So this means that the number of elements in A would be subtracted and I would end up getting 6. That is the C answer. All right, so we are done with this question as well. Now we have 26. Okay. B minus A is a subset of. All right, so this basically means that I have a set that is B. And when I'm doing B minus, I'm basically still having every element of B except those I have in A. So this is going to have some of the elements of B, but not those which I have in A, right? So it would be a subset of B, because like if this is B, and let's say if this is A, if this is B, and if this is A, when I'm subtracting B minus A, I would basically not have this part, okay? I'm only going to have this part. So this part is basically the subset of B. So B is the answer. Okay, this is done. Now let's talk about the 27th question. Okay. Now here, before looking at the question, I would like to explain something. So we have two types of things. One is a logical statement, and then we have its equivalence in set theory. Okay. So if we have something of this type, it would basically mean A union B. And if we have this, we are going to get A intersection B. Okay. So this is what we should know. And why I shared this, you will get to know that. Okay. So the question says if X belongs to A union B, then so we have A, B, C, D options. In A and D option, you can see the sign right here, right? So this is basically what we have in a logical statement. We have to convert it to set theory. So obviously, if X belongs to A union B, let's look into the B option, right? B option says X belongs to A, but X does not belong to B. Now, this is something which we are not sure about. If X belongs to A union B, it means that X belongs to either A or B or both of them. Like, we are not sure about this, that if X belongs to A or if X belongs to B. So clearly B and C cannot be the answers. Now, if we talk about options A and D, we have to use this. Okay, so in mathematics, this is the logical statement, and here we have its equivalence in set theory. If we have this, we write it like this. If we have this, we write it like this. Okay, so in our question, we have X belongs to A union B, right? So we have union, we have union. So its equivalence in the logical statements, like it would be equivalent to this logical statement, right? With this sign. So clearly D is the answer, right? So once we are done with sets, we are going to discuss groups as well, and then you'll get a better idea about these questions. Okay. So for now, just know that D is the answer the because in set theory, if we have A union B, an equivalent statement, an equivalent logical statement would be this one, right? So we would have this sign right here. Okay, so D is the answer. Okay, now we have 28th question. It says if A is ABC and B is 2, 6, 10, then number of elements in A cross B. Again, A cross B is going to be a set of ordered pairs where we are going to have A, B such that A belongs to A and small b belongs to this set, right? So we know that we are going to have an ordered pair in this set, okay? Now we need to know the number of elements. Obviously, we are going to have an ordered pair of this type. Now, obviously, we know that the small a belongs to A. And in capital A, we have three elements, right? Number of elements in capital A is 3. And number of elements in the set B is also 3. So I can have 3 options here and I can have 3 options for the set. So this basically is going to give me 9. So I can have 9 such ordered pairs in this set. So B is the answer, right? So obviously we knew that this set would be made using A and B. A has 3 elements, B has 3 elements. I simply have to multiply 3 into 3 because in total I will have 3 choices here and I will have 3 choices here. So 3 into 3 is going to give me 9, right? So 9 is the answer. So B would be the answer. Okay. Let's talk about the last question now. If A and B are any two sets, then A intersection B slash A. Let's write it down easily. A intersection B minus A. Okay. Now let's have a closer look of B minus A. B minus A is going to have all the elements of B excluding the elements of A which I had in B as well, right? So this set right here has only the elements of B. Whatever element of A we had common in B has been removed because of this part right here, right? So this means that this set and this set, they have nothing in common. If they have nothing in common, their intersection would result in an empty set. That is basically null set. So A would be the answer in this case. Right. Okay, so we are done with these questions.